Okay, so let's get started with the demo session. So currently I am over my GitHub console. So let me go to repositories and let me copy this repository. So the repository that we'll be working on is Monstack Ops. So let me go here and let me copy this and let me go back to my VS Code and let me clone the repo. Git clone, Control V, and so it's cloned. So let me go back here and let me go to Terraform, and inside Terraform here we can see the EKS.tf Terraform file. So let me go inside Terraform directory. Okay, first of all, let me go inside my Monstack Ops directory. Okay, ls, and let me go to Terraform. Let me clear this. Okay, so here we can see this is the eks.tf that is created. So let me initialize Terraform first. So Terraform init. So make sure you have Terraform installed on your device so that it will be working, else it won't be working. So okay, as I mentioned, so this EKS file consists of all the VPC details of the subnet details. So we have two public subnet, my public subnet 01 and 02 and so on. So here we can see Terraform has been successfully initialized. So after this initialization, here we can see this file and these files are added over there. So this is how state is being managed here. So let me clear this and let me run once. Let's see if our configuration and things are working fine or not. And also one thing, let me go to eks.tf, and also I need to add the access key and secret access key here. Okay, so looks like retrieving AWS details, so same. So we do need to provide the credentials, else it will be giving this error that we just saw. And let me also copy the secret access key. So this is being copied and pasted. Okay, control V. Let me save this and let me run this Terraform plan once again. Okay, so here we can see plan 26 to add. So after running my Terraform apply command, so it will be adding 26 resources to my AWS account. So let me clear this and let me apply Terraform apply -f. Okay, sorry, not -f, auto approve. Okay, so serially we can see the AWS resources are being created. So let me go to my VPC and let me refresh. So here we can see, so 10.0.0./16 range VPC is created, which is the same one that we had specified. And let me go inside this. Okay, so we could see two public subnet. So public subnet is attached to this route table, and this route table is attached to this network gateway, as we can see here. So let me go to public subnet 01. So as we can see, public subnet 01 is 10.0.1.0/24, which is this one. 10.0.1.0/24, and we have subnet 2 that is 10.0.2./24, and so on. And here we can see the internet gateway, here we can see route table, and here we can see internet gateway associated with route table. Then we see subnet associated with route table. So accordingly, this is the flow that we are defining over the Terraform file itself. So this is the VPC section. So let me also go to EC2 section. So here is EC2 section. Okay, let me remove this. I don't think this is the one. So let me refresh. Okay, so this is the running one. So I can see. Okay, let me see. Instance state equals to running, so that we won't get confused. So here we can see this is the current one that we have set. So this is in the running state. So let me go and connect to this instance. Also, let me see if the instance I think it's over the last section. So AWS EKS cluster kubectl server. So this is the one. So currently we have instance type selected as T2 micro. So I don't think this T2 micro will be performing well in our case. So I do need to change this instance type to T2 medium. So before that, we'll do some changes over our EC2 instance, and we'll be just changing the instance type. So all our changes or all of our downloads and installed will be safe and sound even after changing this. So we can just change the instance type from T2 micro to T2 medium or large accordingly. So let me clear this and let me see here. So let me log in as a root user. Okay, so we are good to go. Now let me go to my readme.yml file, and here let me install the kubectl because it's a kubectl server. So we require kubectl to be installed here. Okay, I need to paste this way. So kubectl is getting installed. So let me also install AWS CLI. So before installing AWS CLI, I need to install unzip because this doesn't have unzip pre-installed. Okay, we are done with this. So let me paste this and it will be installing the AWS CLI accordingly. And here we can see the cluster takes some time. So it might take around 10 to 15 minutes or 5 minutes, somewhere around like that. So let's see how much time will it take. So currently for creating the EKS cluster, we can see 3 minutes is already elapsed. So let's see how much time this takes. So it's getting inflated. And here we can see this is the MongoDB database that I have. So we'll be utilizing this database. So here we can see this is Monstack example. And if I go inside my deployment and if I click on connect, so here we can see this is the connection string that we are using. So here we can see add your connection string in your application code. So I do need to add this application string or the connection string to my application code in order to interact our application with the database and so on. So we are good to go. Now let me go to EC2. So let's see how much time it takes, and also let's see how much time this takes. Okay, so we are done. So let me go back to my readme.md and we can see AWS EKS update config. So this will be setting up our EKS cluster config. So before that, let me clear this and let me do AWS configure here and let me add my access key and secret key here. So let me go here and let me copy my access key and secret key. So as I mentioned, exposing such kind of access keys and secret key this way is not preferred. So since this is a kind of demo one, so I'm exposing this directly here. So and my region will be US East 2 region, other as it is. So let me clear this. So now I'll be setting the AWS EKS update config. So let me copy this and let me paste this here. And here we can see this is my US East 2 region. So I need to change this to US East 2. And let me check for the cluster name, what we had set. Okay, so here we can see the cluster name. So this is the cluster. So the cluster name is PC-EKS. So I need to provide that. PC-EKS. Okay, so cluster stat is creating. So whenever the cluster status is created or is not creating, then we only can update the queue config accordingly. So here we can see it is still on creating state. So we first must let this cluster to be created and then only we can use this. Let's wait for some time until this is created and we'll be continuing again. Okay guys, finally we can see, so apply is complete. So here we can see the cluster creation time. It took around 8 minutes and 8 seconds, and we can see it created the node and node group within 1 minute 52 seconds. So we are almost good to go. Now let me clear this and let me go back to instance where we were, and let me again try to update the context. So here we can see added new context. So this context has been added. So the cluster PC-EKS has been added. So let me clear this. Now we are good to go. Now let me do one thing. As I mentioned earlier, so my kubectl cluster. Okay, so the kubectl server is currently instance type is set to t2.micro. So I'll be changing this to medium, or that will be small. So I'll be changing this to medium for now. And let me do Terraform apply. Okay, let me first plan here, and we could see there is one changes being made to instance type from T2 micro to medium. So let's see how it responds to that. Okay, so here we can see AWS instance kubectl server. So the instance type is changed from T2.micro to T2 medium. So want to change. So here we can see one needs to be changed. So when you don't use, okay, so let me Terraform apply dash dash auto approve. Okay, so let me go to EC2 instance section, and here let me refresh this. Currently you can see it's on running state, so after some time it will be on other state. So these are the two nodes that we have. So our Kubernetes cluster master will be handled by the AWS EKS itself, and for the node where our workload will be deployed will be these two instances. So we have selected t2.small for these nodes. Okay, so here we can see on the running state we have two nodes only. So the kubectl server is currently on stopped state or changing state, kind of like that. So it's still modifying. So this might also take some time. So before that, let me go here and look for the Docker installation command. Okay, so I think, okay, so let me copy this and let's go back to our EC2 instance. So this might take some time. So let's wait until our kubectl server is completed. So here, let's wait for some time. Okay, so finally we can see the apply is completed and one changes has been added. So let's go back here and let me refresh this. So still the server might take some time to, okay, so it's already available and on running state. So let me connect here. Let's go here and connect to this. Okay, so the kubectl server is also upgraded from T2 micro to T2 medium and so on. So let me clear this and let me do ls. So here we are. So let me go and be a root user and let me do ls here. So here we are inside home/ubuntu and we have AWS kubectl, everything in place. Now we'll be requiring Docker and we'll be creating a Docker image out of our Dockerfile. So for that, let me install docker.sh. Okay, so let me paste the code that I just copied. So this is the installation script and let me add execution permission to this file or this script and let's run the install Docker script. So this will be installing Docker and let me go to GitHub and let me copy this. So as of now, we cloned this repo on our local machine. So this VS Studio code, so or Visual Studio that I had opened is my local machine. So we went there and we tried using Terraform command to create the infrastructure. So here we can see the Terraform and the application repo might not be on same repo. So we can segregate that in that way as well. So here API and UI are our application components. So API, here we can see this is the backend of our application. So within this webpacks config.js, so here we can see process.env Mongo connection string. So this is the Mongo database connection string. So I need to change this Mongo database connection string based on my database. So here we can see within connect and driver. So this needs to be updated by this connection string. And I think other it will be as it is. And so Dockerfile, let me first show you the Dockerfile. Till then, our GitHub, okay, looks like our Docker is also installed. So let me check the version of this. Okay, so here we can see Docker engine is of version 25.0.4 and community version is, so this is the client version. So here we can see this is 25.0.4, which is the same one. Okay, everything looks good. So let me clear this and let me do ls. So till now we do not have our repo cloned over this server. So let me go back here and let me go to my monstack OPS and let me copy the code. And let's go back here and let me clone, git clone, control V. Okay, let me paste from here. Okay, clear. Let me do ls and let me go to monstack ops ls. Let me go to my API. So as I mentioned, I need to change the database connection string here. So let me go back to my nano webpack.js. Okay, and so let me go back here and Okay, let me come from back and let me erase everything that is being added within this Mongo URL or URI. Okay, and let me go back here and let me copy connect driver and copy, and let me go to my instance and let me paste this here. And one thing that I need to change is the password that I need to add here. So let me check what the password is, because I remember. Okay, so let me enter my password. So my password is admin password itself. So ADMIN PASSWORD. So let me save this and let me clear the screen. So here we can see everything is on place. So let me go back one step. Let me do ls, and here we can see this is the Dockerfile that I was talking about. So let me check the Dockerfile here. So here we can see we have two stages, UI build and API build, and it will be packaging the app accordingly. So it will be copying the build from this first build, and it will also be copying the files or the packages from the second build, and it will be running the whole application as a third build, and it will be packaging it accordingly. So let me not delve into this further. So let me do ls, and here is the Docker file. So docker build -t mon image or mon API image. Okay, let me not confuse this. So let me write mon image here and let me give dot here. Okay, there's a typo here. So let me add docker docker here and let's run. So this image creation might also take some time. So let me go back to my VS Code and let me go to readme here. So now we need to create a ECR, Elastic Container Registry. So for this, let me go here and let me copy this. So let's wait until it's done and we'll run that again. Okay, so the image build is successful. So let me clear this and let us check Docker images. So here we can see we have our images. Sorry, the image located here. So as I said, now we'll be creating a AWS ECR, so Elastic Container Registry, for storing our the Docker images. So let me paste this here. And here one thing that we need to change is I need to provide my AWS account ID. So this AWS account ID will be passed from here. So let me copy this ID and let me paste this here. And also one thing that I need to do is AWS login username, and reason is US East 2. Okay, so I think this will work. Okay, so the login was successful. Now we'll be creating a Okay, let me go back here and let me open this over VS Code and let's run the next command. So now we'll be creating a registry. So for this, let me change here itself. So repository name will be, let me set this to mon API. Okay, so let me go and copy this and let me paste this here. Okay, so here we can see the repository, and repository name mon API, registry ID is this one, repository URL is this one. So let me copy this because we might need this time and again. So I don't think it's copied. So let me copy this from here and let me go back here and ECR and let me paste this here. Okay, so far so good. So let me create this, and what we'll do is now we'll be tagging our Docker local image to our you know to our ECR one. So mon image docker, I think docker tag MERN image, I think the tag is latest over there, and my new URL will be this one. So let me do this. Okay, I think. Okay, so let me set this as version 1. Okay, I think the spacing is missed. Okay, so the tag is successful. So let me check Docker images. So here we can see this is tagged as version 1 and so on. So let me push this docker push, and let me pass this one, copy and paste this one. Okay, let's go back to our ECR. Okay, so here we can see our repository is created and so on. So we are good to go. Now let me do one thing. Let me come back here and let me check kubectl get nodes if it's able to connect or not. Okay, so we can see it's able to connect and it's working fine. So first of all, we'll be creating a Kubernetes manifest file. So here, if I show you, we can see there is a manifest.yml. So we'll be utilizing this YAML file and we'll be creating pods, and we'll be deleting this, and we'll be creating Helm chart and configuring it according to our configuration, and we'll be working accordingly. So let me first go to my manifest file. So here we can see there is two services. So the first one is kind deployment and other one we have is kind service. So here we need to change the image name. So I'll be selecting my repository URL here and I'll be pasting it there. So let me go back to my, and let me edit this nano manifest.yml, and here I'll be changing this to, okay, let me remove all of this and let me paste. Okay, I think I missed one thing, so I also need to define my version. Mon API colon version 1. Okay, Control X, Y, enter. So let me clear this and we are good to go now. kubectl apply -f manifest.yml. Let's see if everything's good. So here we can see the deployment and service is created. So let me do kubectl get all. Let's see our pods. So 5 pods out of 5, 3 are ready, which are on running state, and 2 are still on container creating state. And we can see the service, and we can now actually access this application using this endpoint. So let me copy this and let me paste this here, and let's check if it's, so the DNS propagation might take some time because it's just getting created. So let me first go to this and let's check if the load balancer is created or not. So let's go here and check for the load balancer. Okay, so this is the load balancer that just created A8 to B, right? So here we can see A8 to B. So this is the same one. So let me copy this and let me go to incognito once and let's check over there, because I think it's cached already, and so this might be not reflecting. Okay, so let's check the logs for this ones, kubectl, if there's an issue or not. Kubectl logs, and my, okay, I think it's not copied. Let me copy this. Let me erase this from here and let me paste this here. Okay, to the cluster majority server Mongo connection string. Warning, no slabs in library, password will not be sanitized. So I think the database connection is successful. Here we can see the connected to the database. So let me clear this. I think the DNS issue it still persists. Okay, so it looks like it's getting done. So here we can see CloudCast Nepal to do application mon. So these are the databases or the data that were already added. So this is the same one that I am using. So previously, if you see, I have a different video where I had deployed MongoDB as a containerized workload, but currently we have database separately and we are hosting it over the MongoDB itself. And our API is only hosted over the containerized or as a container or pods and so on. So let me create one task. So this will be Helm. Okay. Package using Helm. Okay, so the assignee will be me myself, so Shekhar Khanal, and this is in progress. So let's submit. Let's see if data is getting persisted. So yes, we can see it's getting done. And also how complete pending video editing. So so it's already completed. So let me change this one to, okay, in progress to done. Okay, completed. So let's submit, and here we can see it's completed. Okay guys, so almost we are done. So now let's go back, and I think I have Helm installed already or not. So let me clear this and check if Helm is installed or not. Okay, so we do not have Helm installed. So let me go back here and install Helm. Okay, let me clear this, and we are almost good to go. Now let me let me do ls here, and there is a Helm on stack, so I won't be utilizing this. I'll be creating a separate one for this. So Helm, let me do dash dash help, and here we can see Helm search, Helm pull, Helm install, and kind of thing like that. So first of all, let me do one thing. Okay, so these are the kind of things. So here we can see we are trying to create. So I think other parameters will be Helm create a new chart with the given name. So create Helm create and the given name. So my name will be Helm create, and I'll be giving this web app hyphen Helm hyphen chart, or kind of like that. Okay, so looks like I misspelled. So it's been spelled as web app hyphen Helm hyphen chart. So no worries. So let me go inside my, okay, cd web app. Let me do ls here. Let me clear this, and here we can see. So let me go inside templates once. So except my deployment.yml and service.yml, I'll be removing all of this because I won't be utilizing any of those. So rm-rf nodes .txt underscore helpers.txt, this one, and hpa horizontal pod autoscaler one, and we also won't be using ingress one, and service account one, service account.yml, and also this test folder. Let me do ls. So everything is deleted. So let me do ls here, and let me go one step back. Let me do ls, and so first of all we'll be utilizing the values.yml. So let me go to values.yml, and I'll be creating values.yml here. So let me do ls. Okay, nano values.yml and replica. So for the image, let me go here, and I'll be selecting the replica to 10 and the image. So repository, I need to pass the repository name here. So for this, I'll be passing my repository name that I have copied here. Okay, so this is my repository. So let me paste this. Okay, I think it won't be pasted. Control X, Y. So, okay, let me cancel. Okay, so let me do values. Okay. Okay, looks good. Repository, and let me paste this. And for the image pool policy, I'll be setting this to always. If not present, won't be catering to our specific need. So replica count, image repository, and pool policy, I won't be utilizing tags. And for this one, image pool secrets, I don't want this name override, full-time override, service account. So as I mentioned, we do not have service account. So as I removed from the templates itself, and security context pod label, I won't be utilizing. I will be requiring this service file. So I'll be adding this one, and I'll be removing all the others, ingress one, TLS, and resources, and so on. Okay, so we are good to go. Now so this is the one, and application name. So I'll be providing application name. I think service is also not required because I'll be hard coding this over my service.yml. So let me remove this as well, and let me do one thing. Let me add application, and let me give a name to my application. So that will be web app. Okay, so let me cat once values.yml, and here we can see the replica count is set to 10, image and the repository is changed, full policy is also changed to always, and application is set to name. Let me clear this. Now let me do ls and let's go to charts.yml, and here we can see. Okay, so let me go to my templates, cd templates. Okay, I am at this one, so cd cd templates ls, and let me do nano deployment.yml. Okay, so in this as well, what we'll be requiring is values.replica count, right? Values.replica count. So this will be calling the replicas that we have. Okay, from here I'll be changing most of the things. API version kind, metadata, and okay, container chart name. Okay, within spec, or let me do one thing. I'll be copying and pasting this from my file itself. So let me do. Okay, let me also remove deployment.yml as well, and also remove my service.yml here, and nano service.yml, and let me go back to my code. Helm on stack. Let me go to template. Okay, I don't think this is the one. So here, over template. Okay, so let me go to deployment.yml and let me copy this. So I only want my deployment.yml to be here. So let me go back here and okay, so nano deployment. Okay, everything is in place. Now let me nano service. Okay, let me go back to my templates and let me go to service.yml and let me copy the code here and let me paste this here. Clear. Let me do ls cd ls and let me cat or nano to my chart.yml, and I'll be removing all the things here and I'll be adding this charts one as well. Okay, that will be my chart.yml, right? Okay, let me paste this here and let me save this. Let me clear this. Let me go one step backward. Let me clear this. No, now we are good to go. We have almost changed the. Okay, so before packaging, let me show you what kind of things that we added. So let me go to cd web app helm and ls. Let me go to template as well and let me get my deployment.yml. And so here we can see everything is as it is. So metadata and the name we are selecting from values.yml, where we have application name, and that for replica we are adding the replica count over the values file, and we are calling this over here from there, and we are also adding repository name that I added over values.yml, and we are referencing this here, and we also have image pool policy which we have added over Helm package, and we are referencing here. Everything goes as it is. And also let me show you my service.yml, and for service.yml as well, so name is being called from there, labels run, so application name is being pulled again once again, and here we can see the selector app name is accordingly same, and the type here we can see is set to load balancer. So let me clear this and let me do ls here. So let me go one step backward and let me do ls here. So one step backward, let me do ls. Now we need to package. So for this Helm package and my web app starts, right? So let me do ls. So here we can see this is the packaged file that we got. So let me do kubectl get all once. Okay, so this was created by running or applying our manifest file. So I'll be deleting the deployment kubectl delete -f manifest.yml. So let me delete this. So the both will be deleted. Else we'll be having a problem because we already have a service named web app here, and after creating the service from using Helm, it will be causing trouble. So I'm deleting this so that we'll be having a clean installation and we'll be using Helm. Okay, so this is completed. So now I'll be kubectl get all. So here we can see we have a single service, that is cluster IP, that is utilized by the cluster itself. So other than that, we do not have anything. Now I'll be installing the Helm. So Helm install, and I'll be giving this release name as release 1 or release -one, and I need to give my chart -0 dot. Okay, so I don't think this is located here or what. Okay, so I need to provide this with Helm release 1. Okay, Helm install release and web Helm chart -0. Okay, why isn't it showing me here? Okay, so the package is named differently, so that was the reason, because that's the guess. Alias release, copy, and let me paste this here. Okay, the name is set as release only, no worries. Okay, let me do kubectl get all. Okay, so here we can see 10 pods, out of which all are still not ready. So error image pool. So looks like there is a issue pulling the image. So let me go back to my cd mon. Okay, web app Helm chart. Let me go ahead. Let me go to my cat values.yml. Okay, so I had not added the version here, so that was the issue. So let me go here and nano values.yml, because container they are running based on this image, and if the image itself is misspelled or kind of thing like that, so it won't be working. So now what I'll be doing is I need to uninstall the previous release. So let me do that once again. Helm uninstall. Okay, release uninstalled. So let me do kubectl get all one. Okay, this is the only one that we have, so I think this will also be deleted. So let me check once, and if that's gone, so we are good to go. I think it might take some time, or let me delete this by myself. Kubectl delete, because this will be causing problem here. LETA and control P. Okay, I think this is not copied yet. DELETE and service web app, copy paste. Error from the, okay, looks like it's already deleted. Yeah, so let me clear this, and okay, so let me package this Helm package. Okay, let me do ls. Let me go one step backward. Let me do ls. Let me remove this web app Helm chart and Helm package web app Helm chart ls. So this has been packaged. So let me copy this once, and let me go back here and Helm install pa. Okay, release release 1, and let me paste my this file. Okay, so this is deployed. So let's go here. kubectl get all. Okay, so all the pods are running, and we have this external IP. which is the IP for the load balancer. So let me go to my private window once and let me paste this and let's refresh. So as I said, the DNS propagation might take some time. So let's wait for some time so that it will be reflected. Okay, let me go here, see if load balancer is created or not. So here we can see this is the load balancer. Why isn't it still getting DNS? Okay, so I think it's done. Okay, so here we can see package using Helm. So we have packaged using Helm and everything is completed accordingly. So I am almost done with this. So also what I had mentioned on the video was that we'll be pointing this we're using our own DNS name. So let me first go to my domain section. Okay, so here we can see my domain name is here. So I am inside my portfolio section over here, and over the DNS, if you see, I have added the name server. So this name server are of AWS. So I have hosted this domain, or yes, I have hosted this domain over my Route 53. So let me go to my Route 53 from here. Okay, so currently I'm inside my Route 53 domain. Okay, so this is the hosted zone. So this is a public hosted zone, CloudCast Nepal. So I'll be adding or creating a record for this one. So my subdomain will be www.cloudcast Nepal, and the record will be CNAME type, and this will be the value for my. Okay, so let me go back here and let me copy this from here itself, DNS name, and let me paste it over my DNS. So this will be it, and let me create the record. Or also let me create one of the other record with the subdomain. Let's say monitoring, and this will be CNAME record and create records. Okay, so let me refresh this. So here we can see it's being TTL is 300 seconds. That means 5 minutes. So let me do www.cloudcast.nepal.com and also monitoring.cloudcastnepal.com. So this will also be working fine. Here we can see the cloudcastnepal.com is working fine accordingly. So we are good to go.